Okay. Your attention, please. Thank you. Okay, here's the deal. I'm pretty excited because this is our last new lesson of the year. Can you guys scooch back, please? And then after today, we have a test Friday, and then from Monday on, everything is review for the Regents exam. If you'd have said to me that I was going to get my knees replaced and we would still have 12 days of class review for the Regents exam, I'd have said, man, I don't know if we can pull that one off. But we are going to pull it off, so it's a good thing. All right. This particular quiz, I thought you would do much worse on. I thought the highest grade in the class would be a 50. Yet there were probably 4 or 5 75s and 7 or 8 65s. And that's either a credit to the fact that you have outstanding memories, and you remember when I went over this, I kind of doubt it because I really did it quickly right at the bell for about a minute and a half, maybe 2 minutes one day. Or it's so easy in some respects that you just figured out how to do it on your own. Either way, it's a good thing. Now, I literally said to you that it doesn't matter how you do today because once we go over this, you will do very well tomorrow. And I believe that with all of my heart. Look, residuals mean this. You know how you do a scatter plot?
Yeah.
And then you draw a line of best fit?
Yeah.
A residual is how far away it is from the line of best fit. So all you need to do is plot it. Now look, this is the x-axis, there's the x values, and the residuals are the y values. So I'm going to go to 2, 2, 3, 1, 3, negative 1. And yes, you can have 2 with the number 3. That means on the scatter plot there would have been 2 inputs of 3 with different outputs. This is not a function. It's related to scatter plots. 4, negative 2, 6, negative 3, 7, negative 2, 8, negative 1, 9, 2, 9, 0, and 10, 3. Some people connected the dots. If you connected the dots, I only gave you 15 points out of 25 for doing this. If you did not connect the dots, you got full 25 out of 25. Okay?
But I thought
So-
that was the line.
Did you know that?
Yes.
You just forget to draw the line.
Hey, I can't hear. What's that?
The last one you did is 10-4. So
I did 10-4, I'm sorry. Thank you, 10-4.
Oh, I just crossed mine off.
Don't worry about it. Now, is that hard?
no.
No, I said to you that once you see this, you'll see that it's really easy. This is literally an old Regents exam question. It was from August of 2014. The next part of the question is the part that I knew there was no way in the world you were going to get right because we didn't even talk about this in class. It says, using the plot, assess the line of best fit. Okay. This is a poor line of best fit. Now, if it was a good line of best fit, then the residuals would be very small. Do you agree?
Yeah.
Remember, residual means, if I drew, here's my line of best fit. Residual is how far away from the line of best fit it is. Now, if it's really close to the line of best fit, wouldn't you say that the line of best fit is a good line of best fit? If they're really far away, wouldn't you say it's a bad line of best fit? Anytime that it forms a pattern, it's a poor line of best fit. So the answer to the last part is that it is a poor line of best fit because it forms a pattern.
Wait. These dots that are close.
Wouldn't that be a good?
Oh, some of the points are good. These guys are good, these guys are good, but look here, look here, look here, look here. You're not really looking for a pattern. Also, notice I've got 1, 2, 3, 4, 5 below, and some of them are really far below.
Oh, only the ones above the line.
You want some above, some below, about the same number of each, and you want them really close. This, if you look at the blue, this would be good lines of best fit,
Why?
because they're all really close.
Oh, the X is the line of best fit?
The X means the value that, the X is like the line of best fit value, and the Y is how far away these little blue dots are. If the little blue dots are all close to this, then that means it's a really good line of best fit. It means that the residual is waste left over. It means the residual leftover is really tiny. It's almost on the line. But these red dots are pretty far away. Furthermore, Now, you should not connect the dots in the graph, we already went over that. But if you look at it, you're kind of almost making a problem, right?
Yeah.
Anytime you see a pattern being formed, it's a poor line of best fit. You want randomness and really close to the x-axis.
That would be a good line of
Here's data plots that would suggest it's a good line of best fit. See how there's really no pattern there? And everything is pretty close compared to the red? Do you see that?
Yeah.
That's a good line of best fit. That means all the dots are really close to the line of best fit. The further apart they go, the worse the line of best fit would be, in the sense that the further away the residuals are. Now, if they form a pattern like this, or any other pattern, it means that it's a poor line of best fit. It means basically that more of them are gonna end up here and some here, and it should be slid over a little bit to balance it out, okay? So, if you see a pattern, poor line of best fit. What did I just say?
If you see it.
If you see a pattern, poor line of best fit. Okay, so we just plot the residuals, and then the next thing that we do is, if it says how good a line of best fit is we look for a pattern. If everything's random and tight to the line, that means it's a very strong correlation, and it looks really, really good. If everything is a pattern, that means it is not a good line of best fit. Okay. So now, let's go to the back, where almost everybody got it right. And that's good, because the first time we gave a quiz like this on the back, it wasn't necessarily so. The one thing a couple of people forgot, if you got 45s, you tended to be one of these people. Let's see here. It went something like this.
369.
Remember, this is a picky little detail, but to me, it's extremely important that we go over these picky little details. This should be over just a little bit here. The reason it's very important that we go over these picky little details is because on the Regents, when I grade this question, this is worth 3 points. The only way, I repeat this, I've said it yesterday, I say it today, I say it every day. The only way to get full credit is to be perfect. Now, on this particular problem, let me give you the correct answers, and then let me show you why I have to be picky. Here's the graph. It should be slid over a little bit to the left, but whatever. It should have went through here. All right, that's fine, whatever. The picky thing is the arrows on the ends. We'll come back to that in just a minute. The first one says if g of x is f of x minus 2, how's the graph affected? Look, this, let me put it out here. F of x, g of x equals f of x minus 2. This is outside of parenthesis. Outside parenthesis is vertical shift. So you're going to go down 2. So the first part is down 2. The next one says g of x is f of x, I think it says minus 4.
Yeah.
If it's inside the parenthesis, what is it? It's not vertical shift, what is it?
Horizontal.
Horizontal shift. And it's reversed. So it's 4 units to the right. So what we're looking for is 4 units to the right on that, yes.
When we write our answers, right, this would be like a part 2 question?
Part 2 or part 3, yeah.
Do we have to write, the vertical shift would be moved down to it, or you would just down to?
I think down 2 would be fine, all right, I really do. Now, some people went so far as to draw all 3 graphs and then summarize, you could do that too. Here's the thing, let's say this is worth 3 points. You're going to get 1 point to do the graph properly, 1 graph to write down 2, and 1 graph to write to the right 4. Now here's the problem. To me, here's the essence of what they want you to know. They want you to know how to do an absolute value graph, which you can do on the calculator, and I looked, everybody had really good looking graphs. They want you to understand that this guy here means vertical shift and go down 2. Just about everybody got that. They want to see if you understand in the parentheses is horizontal shift and that it's reversed. Everything looked good. Now, if you can do all 3 of those things, you clearly understand all the parts of the problem. They will, however, get really, really picky. If they ever give you a domain from, say, 0 to x to 4, that means I only look at the graph where x goes from 0 to 4. Whatever graph is in here, I'm going to look at. I'm not going to look at the rest of the graph. I just want to see 0 to 4. The problem here is they didn't give you a domain, which means they want to see the graph forever. If they want to see the graph forever, what do you expect to have on the ends of the graph?
Arrows.
Arrows. So they would take off a point for not having arrows. Now, that's a picky, stupid little detail compared to how to graph it, horizontal and vertical shift. That's the guts of the problem. But because of how they grade this problem, it's worth just as much if you do that wrong. So you need to be aware of that. I would despise the people who want to get an 85, who are working for it. Can you imagine getting an 84 because you leave off the arrows? I would be furious. Or a 90. Or even if suddenly the light of day has hit you and you start really cranking out a lot of hard work, you say, I am not failing this test. And you start doing really well, and you end up with a 64 because you leave off arrows? Are you kidding me? So I have to correct you every time you don't do it, so that you get annoyed, and then you remember on the test. Question?
You put the arrows, but it has that.
That's a great question, and I think it wouldn't matter. I don't really know the answer, but just suffice it to say, if it says an interval, you just do it over the interval. If it doesn't, I expect to see arrows. All right, so, do you understand now when I said that you would hate me when I gave you the question, and you did better than I thought, but it would be really easy tomorrow? Right, okay? So just look it over, and don't, please, don't do the Lippener Bacon technique of not looking at it until the between periods, and then taking it out and go, wait, I got a question. Take it out at home, look at it for 2 or 3 minutes, look it over, everything will be okay. Yes?
It's the
Liponer, whatever it is. Okay. Now, today's lesson. One of the really sad things to me about the Common Core is that I have lost this unit. This used to be my favorite unit of the year, and it's not happening. All right, which is an example of categorical, oh my God. Oh. Yeah, that would be it. Boy, I made a test today, and I seem to remember something about categorical data. Okay, that's it. I'm not saying anymore. Okay. Which histogram is normally distributed? Which one do you think is normally distributed? Choice 1, right?
Wait, we didn't answer the top one.
I put 2.
Yeah, we did. It's
No, 2 is a little bit skewed.
Well,
It's
it
not
doesn't-
grossly skewed.
Well, if it was,
Compare 2 to 1.
no,
One's like perfect.
okay,
Right,
well,
exactly.
yeah, but if it's normal,
Why-
it's not-
why-
No, normal
Why
means
is-
it makes a bell shape. It's symmetrical. That's what normal means. Okay, yeah.
Number, like the first question
Mhm.
is 3, right?
Yeah.
yeah.
The one, the eye color one?
Yeah.
Yeah. Categorical data is things that can be put down into categories. Think of it as being often a lot like qualitative data. An example of categorical data would be something like this. What's your favorite kind of music? Okay. Favorite kind of music? Interesting. All right? This is not categorical. What's your height? What's your weight? Those kind of things. Okay? All right, so now, Barb is making the measurements of a homemade table that she says is in the shape of a right triangle. 2 sides of 33 and 56. What should the measure of the hypotenuse be? So I would do 33 squared plus 56 squared equals x squared, and what does it work out to?
2.
Choice 2, 65. Do I have a second? Do I have a second? I have a second. Do I have a third? Do I have a third? Third? Okay. All right, so that would be it. To me, I get the idea that that means that you are not,
Stupid.
no, it means you didn't do it. Okay, so as I take a look at this, I see that most of the stuff didn't print out for today's sheet, so let me do that right now. This is I love this stuff, and I'm really, really sad that it's not really a part of Common Core curriculum. In fact, there's one reason I do this, and one reason only. I cannot find this material anywhere in the Common Core curriculum at any point in time. However, I have a ton of respect for a teacher at the high school named Mrs. Daly, and she teaches it to her students. And I have respect for Mr. Angelora at Saxton, and he teaches it to his students. And I've asked them once why, and I don't completely understand their reasoning. But they seem to think that they could ask a question about this. Now, I have been through 3 practice regions, the only 3 they've given, and they've never asked a question like this. So I don't know that this is going to be on the regions. But it could be because of them. And I would have this sickening feeling in the pit of my stomach if I looked at the test and saw one of these on there and didn't cover it with you. So, I'm going to cover it with you. We will hit it some during the review. We will not go crazy. And it's all about reducing algebraic expressions. And this truly is my absolute favorite topic of the year. I hope I have the time to give you the good version of this, all right? So you've already done some reducing. Let's say you had 20 a to the 5th, b to the 4th over 5a squared b, and that's it. What would that equal when I reduce it? What?
4a to the 3rd
Yeah.
and b to the 3rd.
That's right, because there's really a 1 here, and we subtract exponents. Everybody agree?
That's what you do.
Well, that's the type that we know, and that's the type that they say should be on the regions. But now I'm going to give you one that looks like this. Five x plus 20 over 5x. The big difference between this problem and the other problem is that plus in the middle. That changes everything. I look at that as mathematical matrimony. We're going to give you the short, sweet version of the fun. When we have a full time, and this is a really, really fun lesson. Anybody going out with anybody in here? Is there anyone in this room who has a significant other? Anybody? Anybody? Nobody is going. This is a loveless class. So sad. So sad. Why?
No,
No. Listen, of all the women in the world, you can include Hollywood, you can include music.
I'm not taking this, Parker.
Parker, of all the women in the world, Hollywood, all that other kind of stuff, who's the most beautiful woman in the world that you would love to be?
Your mom.
Oh, stop. I need a name, don't think too long and too hard. There's so many to choose from, I know. Who? Anna Kendrick, okay. So let's say that Parker is going out with Anna Kendrick, and they're at a party together. Now, we all know the rules for going out with somebody. The skeeviest thing you can possibly do is cheat. That's like lower than low. No one should ever cheat. So, let's say, I don't even know who Anna Kendrick is, but let's say that Anna Kendrick's at the party with Parker, and in walks some other guy, and she just kind of like leaves Parker alone, and then goes in some dark back alleyway, and she's hanging out with this other guy and kissing him and so on and so forth. Isn't that like skeevy and wrong and terrible and rotten? Isn't that like the worst thing I can do?
You can relate to that.
Okay, it is, trust me. Now, let's say the opposite occurred, and Parker sees a girl that's even more beautiful than Anna Kendrick. And she walks in the room, and Parker's like, yeah,
Parker
get
likes
out.
girls.
Get out of here, stop, get out of here. And then Parker grabs this beautiful woman, and he starts like ditching his date, and he starts flirting with her, and putting his arm around her, and putting on the moves. Now, he's being a player, and this is really, really bad. You don't want to do that. But, let's say that Parker and Anna look at each other when these two other attractive people walk in the room, and they look at each other and they go, you thinking what I'm thinking? And she looks back, you thinking what I'm thinking? And they go, let's break up. And then they break up, and they go each date one of those other people. Is that skeevy?
No.
No, it's not, because they agreed ahead of time that it wouldn't be. The truth is that when you are bonded to someone, when you are going out with someone, you cannot ditch them. You can't cheat on them. You are bonded. So this plus is mathematical matrimony. It is bonded. Now, the instinct of most student would be to do this. This is what students want to do. Die! The answer is 20. No, I'm Mr. Lindquist. Now, so they want to say 20, but 20 is dead wrong. If you do that, it will be as wrong in a math sense as cheating would be in a relationship sense. So what we have to do is this. Years ago on TV, there used to be a commercial. Anybody here have a dog?
Yes.
Anybody here feed the food kibbles and bits?
Yeah.
Okay, well, there was a TV commercial where a little kid went in the living room, and he go, kibbles and bits, kibbles and bits. All that he wants is just kibbles and bits, kibbles and bits, kibbles and bits. All that he wants is just kibbles and bits, and a little puppy be running around chasing the kibbles and bits. Kibbles and bits, kibbles and bits. All that he wants is kibbles and bits. So what we're going to say is this, ready? We're going to sound like Chucky in the movies, the little psychotic doll. We're going to go like this, ready? Factor and kill, factor and kill. All that we do is we factor and kill, factor and kill, factor and kill. Yeah, you factor and kill. Do you see? Die! The answer is x plus 4 over x. Now, on the serious side, watch, listen. I said to you the following phrase. Factor and kill. All you do is factor and kill. I factored 5x plus 20. It's 5 times x plus 4. And now, is there a bond between the 5 and the parenthesis? No. Is there a bond between the 5 and the x? No. So I can kill the 5's because they're not bonded. See, I can't kill these 5x's because this 5x is bonded by the plus sign to the 20. So if you factor first, you get the bond. It's like breaking up. And then you can go do what you want to do. Okay? So I factor the 5 and then I reduce it. Let's take a look at the next one there. It says what? X squared minus 3x minus 4? Is that what that says?
Yeah.
Over what? X squared minus 16?
Yeah.
Okay, so factor the top. Yeah, do it. Factor the top. When you factor it, I think you get x minus 4 times x plus 1, right? Factor the bottom.
What is it? Is this,
X minus, oh, yeah, x minus 4 times x plus 1.
is this gonna be on the test tomorrow? I mean,
Oh, yeah, there are 3 questions.
when is it?
Yeah, it's gonna be just like, it'll be one just like that one.
We have a
All right,
test.
next one.
I mean, Friday.
X minus 4 times x plus 4. Can everybody factor those? Right? X squared minus 16 is x minus 4, x plus 4. X squared minus 3, x minus 4. Now watch. Die. I can kill the whole thing. Done. The answer is x plus 1 over x plus 4. That's it.
X plus what?
X plus 1 over
Yeah, I
x
see.
plus 4.
I see.
That's it. So you factor and kill, factor and kill. Go ahead.
When's our test?
Friday. Yep.
Why haven't
This Friday. Yes, 2
Yes,
days.
Parker.
That's my birthday, that's not fair.
This whole fair thing, get over it.
That's
All right.
normal.
I'm going to help you factor here. Ready? Shh. Hey, stop. Hold it. Don't move. I factor the top. I get x times x plus 3. You already know how to factor. I factor the bottom. I get 2x plus 1 times x plus 3. Hey, sit down. What can go die here?
X plus 3.
The x plus 3's. So the answer would be x over 2x plus 1. That's it. That's all. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio.
I look straight at James, yo. I look straight at James. I look.